Assalamu alaikum dear students. Today our lecture is about sanitary landfills. In our last lecture we tried to find out what are the requirements for the layout and design of sanitary landfill. Today we will uh, have a look what kind of reactions are taking place within the landfill and what kind of monitoring is required, how we are going to control the gas emissions, how we are going to collect the effluent, leachate. So all these things, yes, and one more thing, that's about the lining of the landfill. So how we are going to do all these things, today's lecture will be focused on these things. So starting with the basic, that's about the composition and characteristics, generation, movement and control of landfill gases. Basically, our landfill is considered as a biochemical reactor because we are adding something into this reactor in the form of solid waste and water, and then uh, in response to that there is some chemical reaction taking place within that landfill. Thirdly, there is an output in the form of leachate and in the form of gases, landfill gases. So this comprises a complete reactor. That's why we can call our landfills as a biochemical reactor. So the material which is stored in the landfills usually include partially degraded organics. So and other inorganics are also present in the landfill. So that partially degraded material is going to complete its degradation process. It's not possible to finally dispose that waste which is completely degraded. So especially in the case of sanitary landfills, when we have the sources coming from the sludge, coming from the municipal sources, domestic waste, domestic solid waste, so all these things definitely contain biodegradable organics. Furthermore, they are also having already existing bacterial count. Bacterial processes are already in process. So uh, within the landfill these processes will continue based on the conditions. We are just going to consider all those processes which will be taking place. So the landfill gas control systems are employed to prevent unwanted movement of landfill gas into the atmosphere as well as into the surrounding soils. So vertical as well as horizontal movement of gases will be considered, will be controlled, and will be further processed if required. We will go into the detail about these processes in the coming slides. Typical composition of landfill gas. So most importantly, there are two gases which are in higher concentration and volume. Then those are methane and carbon dioxide. Others are also there which include oxygen, nitrogen, sulfides, ammonia, hydrogen, monoxides, and so on. The temperature is usually 38 to 78, and so CH4 and CO2 are the principal gases produced from the anaerobic decomposition of the biodegradable organic waste. Now what kind of anaerobic decomposition is taking place in the landfill? So firstly we have complex organics which will be reduced to mono and oligomers. What are oligomers? Oligomers are in between polymer and monomers. So if you see, then these decomposed and reduced compounds of oligomers and monomers will further reduce to alcohols and simpler compounds, simple chains. The longer chains will be reduced, and then finally we will be getting some acetates which will be converted to CO2 and then H2O and then CH4 and finally released. So these are actually four processes: hydrolysis, fermentation, acetogenesis, methanogenesis. So starting, there are actually five phases which will be constituting all these four processes. In the first phase, it is the initial adjustment. So initially there is some oxygen present. Because of that oxygen level, we will be having a decomposition under the aerobic conditions. Then this aerobic processes will finally convert into anaerobic processes, because the oxygen will deplete and there will be no more oxygen. So there will be a shift of the decomposition process. So the principal sources of aerobic and anaerobic microorganisms is coming from the soil material. Now this soil material can be either coming from our compaction clay layers, or it can be coming from the uh, already in process, already incomplete decomposition processes. So wastewater treatment plant sludges are also enriched with the microorganisms. So those sludges also contain huge quantities of microorganisms. So that is also one of the sources in addition to the compaction clay. Now the recycled leachate is also having this microorganism level. Now second phase is the transition phase. Oxygen has depleted and now the anaerobic conditions has prevailed, and now the decomposition will be taking place in the absence of oxygen. And now in this case you will find that the major indication of the anaerobic process is is reduction. So even in case of wastewater, when you are studying wastewater engineering, even then you have studied that when anaerobic processes are starting, and that is the time when the present compounds, chemical compounds, organic compounds will decompose and will be reduced, and that reduction process will actually change the color of wastewater. Now the same process is taking place here. The process is the reduction process, and in this reduction process nitrate, sulfate will be reduced. Now the nitrate will be reduced to nitrite, sulfate will be reduced to sulfite. Now this conversion is actually due to the reduction process in which electrons are accepted, hydrogen ions are accepted, so E acceptors, electron acceptors. So now we have produced H2S gas in it. This is the reduction process. Now it occurs at -50 to -100 millivolts oxidation reduction potential. Now as you see that the pH of the leachate has started reducing, dropped due to the presence of volatile fatty acids. Now this reduction and as at the same time CO2 is being produced, so the CO2 concentration is increasing. So as a result of this, the pH level is now reducing. When pH level of any of the landfill will be reduced, then it means our CO2, our oxidation demand, COD and BOD will be increased. Now and at the same time the conductivity will increase, and at the same time the solubility of the heavy metals will also increase. So the pH reduction is actually resulting in the excessive COD BOD levels, as well as conductivity will be increased, and as that at the same time the solubility of heavy metals will be increased. This is the impact of reduced pH level. And this why this pH has reduced, it has reduced due to the production of CO2 levels, as well as presence of volatile fatty acids in the landfill process. Now this leads to our third phase, and that third phase is about the acid formation phase. Now what kind of acids will be formed here? Acetic acid will be generated, volatile fatty acids, then these will be converted to the acetic acids. Now the complex organic compounds are first of all hydrolyzed, and this hydrolysis process is actually the decomposition, further decomposition into the simpler products. And then this will be resulting into the formation of VF phase and alcohols. So hydrogen is also produced as a result of the hydrolysis process, because it is the dissolution process. The water will be reacting and at the same time releasing H, and oxygen will be also released. And then this CO2 is the principal gas generated. Microorganisms which are responsible are facultative and anaerobic acidogens. Now continue to this phase. pH of the leachate drops to 5 because of the high concentrations of VFAs and CO2s, and due to the dissolution of VFAs in leachate, BOD, COD conductivity has increased. Low pH values, heavy metals are solubilized. So that's what we earlier talked, that because of the reduction in pH, the COD BOD will increase, conductivity will increase, and the solubility of the heavy metals will increase. So the reason of the leachate recycling is to keep the nutrients within the system, those nutrients which are helpful in the process of decomposition. Now acetic acid and H2O has formed, and if you see that methane, this is now in our phase 4, methane formation phase. Now this acetate will be converted to CH4 and CO2 by the microorganisms which are known as methanogens. So these microorganisms are responsible for the conversion of acetic acid into CH4 formation as well as CO2 formation. Now because the acetic acid now has been decomposed into the CH4 and CO2, as a result of that pH has started increasing. Now concentration of CO2, COD and BOD and the conductivity will be reduced due to this increase in the pH level. And with higher pH values, fewer inorganic constituents will remain in the system, because at low pH the heavy metals has already solubilized, that has already become part of the solution. And now if you look at this graph, you can see that in this methane formation graph we are having higher levels of CH4, and CO2 is also present in this phase. And While all other nitrogen gas and hydrogen gas has reduced in their levels. So next is the maturation phase, and in this phase we are going to understand how our process is going to close. Now this is the final maturation phase in which most of the degradable organic content has reduced. Now this reduction is actually uh, responsible is due to the microbial activity. So the methanogens has played their role. Now all the degradable content has limited to the converted to the CH4 and CO2 mainly. So and at the same time landfill gas generation has diminished significantly. Small amounts of O2 and N2 may be found, and as well as CO2 and CH4, because the gas production is directly linked with the decomposition process. As long as the decomposition process will continue, the gases will be continuously produced. We will be required to continuously maintain the control of these gases. And if these gases are not produced, and that means that the processes of decomposition has stopped. Now in the last phase of maturation, you can see that again small amounts of nitrogen and oxygen can be seen in this graph. If you see the maturation phase, there is a small amount of nitrogen N2 and O2 again produced, and then humic and fulvic acids will be produced, which are not going to be further processed. So this is something about the uh, decomposition process, how it is going to take place. There are about 5 phases, and this is again the description, graphical description, and but it is in colored form, so maybe you can easily trace the generation of these gases and at what phase these gases are being generated. You can check it out here. And now this is the gas production with time, and during the first 5 years there is a decomposition process, and different types of decomposition process are taking place, and as a result of that you can see the activity gas of total gas production is the maximum. Now this decomposition process is gradually reducing with time, and as it up to the year 20, all the decomposition process has closed. Now the movement of landfill gases is based on two methods mainly, and in an active landfill, which are convection and diffusion. Earlier we talked about the movement of contaminants, and then we studied advection process. That advection process was driven by the groundwater flow. So now in this case it's convection, that is driven by the pressure. So the gases will be worked under the high pressure. So when the pressure will be applied under high pressure, in which direction the pressure will be applied, the gases will move. And secondly is the diffusion process. Obviously, as we talked in that case about the concentration gradients, and then the sorption of the gases into liquid or solid components. And sorption is the mechanical dispersion, the same mechanical dispersion as we talked in the groundwater contaminant movement. And these are the movement processes which are responsible for the movement of landfill gases. So the active control of landfill gases will be requiring the provision of the extracting wells, and we need to install these wells once the so for deep landfills with a composite cover containing a geomembrane, 50 to 60 meter spacing is required between the wells. And then in the case the liner is clay liner, soil cover is there, then the spacing is 30 meters. So, and the main thing is that we need to overlap the radius of influence. So the management of landfill gases, this is something very important because these three methods will be used in managing the landfill gases. So firstly, flaring. This is the thermal destruction. So in the end, what we got of the decomposition process, we got CH4 and volatile organic compounds, and uh, these are um, finally released, and then these will be burnt in open air. So it is the flare normally observed at the top of the stakes. So uh, this kind of emissions are normally burned and in the presence of oxygen, and which will be resulting into the formation of production of the CO2 gas, in the production of sulfur oxides, nitrogen oxides, and other related gases will be produced as a result of this flaring process. So this is very important and very commonly used process. Second option is to use the gases produced in the landfill uh, by the energy recovery process. So this energy recovery process is actually the utilization of the methane gas as a biogas, and then running the turbines, and then generation of electricity through the this biogas production. And then gas purification is required because biogas is impure, and we need to purify it. And the most commonly used processes are the membrane separation and the physical chemical adsorption process. Physical chemical adsorption process um, is also the common one as compared to the membrane separation process. But both are efficient methods to purify our gases, biogas produced. Then the composition, formation, and control of the landfill leachate. So these are the leachate sources of leachate, and the composition of the this leachate is having BOD, COD, and other suspended particles, nitrates, phosphorus, and so on. So all these things are the same, almost same, which are present in our wastewater. So if it's almost the same about wastewater characterization and leachate characterization. This is the water balance and leachate generation in landfill. The water is entered from the infiltrate from the top surface, entering into the cover material, and then being consumed in the landfill. Uh, and then gases will be produced, and then water in the sludge is there, and water in solid waste is there, and water vapors can be released from this whole process, and then there is a leachate collection system in the bottom. So landfill liner system, one of the major concerns with landfill of waste uncontrolled release of leachate from the landfill, which must be controlled, and then leakage of leachate containing pollutants may cause soil and groundwater contamination. And then functions of the landfill liner is to eliminate or minimize the impact of this concern. So it need to be properly designed, this lining system. So for the proper lining, you can observe that control of leachate at landfill site. First of all, the most important thing, we need single composite barrier types, in which we are having a simple collection system. First of all is the lining system, and then we have a collection system. You can observe in these uh, figures, there is a geotextile membrane, and then we have 40 to 80 mil. This is actually the unit for measuring the thickness of the sheets, polythene sheets, geomembrane sheets, any kind of paper sheets, any kind of sheet is measured in this. And this is 1 mil is equal to 0.001 inches, so 1,000th part of the inch. So this is how we are going to measure the thickness of the geomembrane liners. And then we have a geonet as well added in this case, which is going to protect. So these are actually the demonstration of the single composite barrier. Again, it is the same thing, and you can find that we have this geonet provided in the secondary composite liner, and similarly geotextile is there, and geonet is there, and then geomembrane is there. So and plus, in addition to this, we have a compaction of 3 feet, 2 to 3 feet compaction. So it's depending upon the nature of waste. We have hazardous waste, we have non-hazardous waste in the sanitary landfills. So in this, these two figures are separately for each category of the landfill. So for hazardous waste, we are having a double provision of the layers, and like geonet is doubled, and we have more compacted clay layer thickness, that is 3 feet, while for the sanitary and combined landfill, we have comparatively different the different provisions. And so this is for the designing of so first of all, we must know for what kind of landfill we are conducting this designing. Then there is a specific range for every layer. So this is kind of comparison. Similarly, we have a double composite barrier type, and again we can observe that we have a fixation of the pipes in it for the collection of landfill of the leachate. So again, this is, you can see that there is a leachate detection layer as well, leachate detection layer, which is just above the compaction layer. So we can see it in the next as well. So this is the minimum liner requirements for the US EPA. So for hazardous waste landfill, we must, so this is the category we were talking earlier. Now this is the category which is supposed to have a double liner system plus LCL. So LCL is the leachate collection, and LD is the leachate detection liner. So this is the if you see this figure, we can have about this is the compacted clay, and this composite secondary liner should have this much thickness, and the permeability, the constant of Permeability must be less than 1 into 10 power minus 9 meter per second. We also need to have a secondary geomembrane liner, and then we are having a leak detection and removal system, and then we are having the primary geomembrane liner, and then the thickness of this is about 0.76 millimeter thickness. So all these are the designing criterias for the landfill, and especially it is for the hazardous waste landfill. So for the designing of hazardous landfill, these are the design criterias for every liner and for every layer. So the primary leachate collection system and removal system is there, and so similarly for the non-liner, for the non-hazardous waste landfill, we have this system in which there is a single liner system plus LCL. So LCL is the uh, collection system, leachate collection liner. So this layer, so leakage collection layer, so this has a comparatively less complex system, and the composite liner is 0.6 meters in thickness, while earlier it was having 0.9 meter thickness, and the permeability and hydraulic conductivity is almost the same. And then you can see this. So please go through these designing criterias for both the um, landfills. And here again you can see the comparison. We have a geomembrane before the leachate collection system in this case, and here again we have the geomembrane, and then composite liner, and then leachate collection system is there. So you can go through the composite liner system. So the compacted clay liner again has its own design criteria. So compacted clay liner are constructed primarily from the natural soil materials, and then bentonite is added to further enhance its uh, retention capacity. Bentonite is a kind of clay, is the type of clay which is having the finest particles. So that means the bentonite is the a much preferable liner, and that's why it is mixed uh, with the other clay materials and other lining materials. So clay liners are constructed in layers called lifts. We have parallel lifts. So the improper material is the waste, and it is covered in this form. And the slope must not be steeper than 2.5 to 1. And on the other end, we have horizontal lifts. Again, here you can go through it. So the requirement of compacted liner is that uh, it must have a hydraulic conductivity lesser than 10 power minus 9 meter per second. And then major influence on the hydraulic conductivity in compaction process is water content, and then method of compaction is important, and then the compactive effort, homogeneity, and avoiding crack and large voids is important in having an ideal compaction compaction layer. So this is again some materials for compacted clay liner with its uh, percentages, like so minimum requirements for most soil liners materials is recommended as here described here. It is explaining the percentage fines and plasticity index, percentage gravels, maximum particle size. So adding bentonite to the liner material can lower the hydraulic conductivity. So bentonite, as I earlier told, it is having the finest particles, so it is going to have a much more retention capacity. So this is the geosynthetic clay liner, and a thin layer of clay sandwiched between geotextile or glued to a geomembrane. So you can just have a look at it here. And the leachate collection system, you can observe the perforated leachate collection pipes are here, which will collect the leachate from the top, and then it will enter into this perforated pipe, leachate collection pipe, and then it will be carried to the outer end, where there will be a tank, and then from that tank it will be taken to the surface for its final treatment, and then again uh, it will be um, disposed. So intermediate cover layers, these are the used to cover the waste placed each day, and I think we have gone through this earlier, so please just have a look and go through these. Designing of the landfill again, we need there are some factors which are important to be considered. First of all is the access, then the availability of the land area, then what kind of method will be required, then after completion, then completed landfill characteristics, surface drainage, intermediate cover material, final cover, landfill liner, and cell design and construction. All these things will be required. So design of landfills include important factors to be considered: groundwater protection, landfill gas management, leachate collection, leachate treatment, and then environmental requirements. So equipment required, and then the fire prevention. Then the landfill closure and post closure care. It is also important because we must know what kind of utilization of this land is going to be done, and then development of long term closure plan is required, and then control of landfill gases, and then collection of the treatment of leachate, and environmental monitoring system must be installed. And then post closure is routine inspection, infrastructure maintenance, environmental monitoring systems. These are the requirements after it has been closed, the landfill has been closed. Still the monitoring is compulsory, because there are still probability of the continuity of the reactions, and there can be some leakage still existing which need to be addressed. So that's something about the basic design criterias which are required to be considered for the design and development of the landfill site. So earlier that we also studied the basic reactions, chemical reactions taking place. So that's all for today's lecture. Thank you very much.